Hello guys, Mathemos right here, and I think it's time I come clean on something. A little while ago, I published a video talking about the store box. It was really 4-base NAS I built so I can back up my work onto a different machine for in the event my Elements drive failing. Well, it turns out, just like the original Octane workstation I built, cutting corners and using low-end consumer hardware has bit me in the butt, and the server failed within 2 days of its commissioning. This was after I recorded the voiceover for the Storebox video. As a result, a good chunk of me working on that video, along with my work within Blender, was still not backed up and I hadn't got a copy of my projects. So this time, I am not cutting any corners and doing everything properly to ensure I have a good, reliable server. So let's start on the base system for this build. I went with a QNAP TS-253A with 4GB of DDR3 memory. I know QNAP isn't the best choice as the QoS has had many exploits discovered over the years. However, for all intent and purposes, this NAS is a PC with an x86 Intel processor and a BIOS that you can easily access. So there's nothing to stop me to put any other OS on it whatsoever. I could even put Windows Server on it if I really wanted to. Of course, that does mean I have to replace the DOM or disk on module, as the 512MB isn't going to cut it. So I bought this low profile 32GB USB stick from SanDisk. Since the DOM is connected via an internal USB 2 header, I thought if I use an internal USB to USB A adapter, I could easily replace it and keep the exterior nice and clean. Additionally, since the NAS was specifically targeted at businesses during its run, the components are, hopefully, better quality than what the Pi NAS was rated for. Of course, you're not going to go far with 4GB of RAM, so I bought a 4GB module to bring it up to 8. You may be wondering why I'm upgrading the QNAP to 8GB of RAM when I said from the Storebox video that, and I quote, "I didn't spring for the 8GB Pi as I felt it wasn't necessary for the roles I hoped to fill, and so the 4GB was more than enough for what I needed." And that is a valid argument. The reason why I'm springing for 8GB is because of some of the software choices I'm making this time around, which we'll cover later in this video. And finally, the main storage drives. This time no expense was spared, and I picked up 2 Western Digital Red Pro drives, each at 8TB of raw capacity. These I picked up at a very good bargain second hand, and since these are Pro drives, they are rated for more server grade, though obviously not quite, durability compared to the consumer Seagate drives from last time. And that doesn't even account these drives are considerably newer and have much less running time than the aforementioned Seagate drives I used. In total, this build cost me £458. So now onto the build. The first thing I did was to remove the drive bays that held some old Western Digital purple drives. Turns out this was used as part of a CCTV system in her previous life. You'll see in this timelapse I had a great problem trying to get the casing off, and for once it isn't because I am weak. Tutorials I watched on how to gain access to the NAS's motherboard also had issues getting the case off. It's just too tight. I found my next surprise, which is that the QNAP uses 2 2GB sticks instead of a singular module that I was expecting. And I quickly discovered that the QNAP doesn't like odd memory combinations, like 6GB in this case. So currently the server is still running on its original 4GB of RAM. The next thing I tried to do was to remove the motherboard as the DOM is on the other side. After removing the 4 screws around the edges, I quickly discovered something else was holding the board into place. Since the system is in working condition, I didn't want to risk bricking it. So I ended up not using that internal USB adapter and instead plugged the USB into the back. It's not ideal, but at least you can't see it when the server is in use. So I've learnt to live with it. You may have noticed that I haven't fitted the new drives and it doesn't have those caddies installed. While installing the new operating system, I've wanted to minimize what drives the server could see to avoid mistakes. So this is the real beginning of doing things properly, starting with the OS. Originally I planned to use TrueNAS Scale. It is seemingly one of the industry standard these days. It's also based on the Linux kernel rather than FreeBSD, which was one of the requirements for me, and uses the specific filing system I wanted to use this time around. However, since I didn't upgrade the one to 8GB, this machine wouldn't meet the minimum requirements to run that operating system, so I abandoned that idea. After some searching, I found that OpenMediaVault also used the filing system I wanted, but it also has a more lightweight set of requirements. And since I already knew that it was also based on Linux, I decided to go with that this time around instead of disregarding it. So I downloaded the ISO image from their website and imaged it in GNOME's disk utility to a USB stick I wasn't using. Once that is done, I plugged it into the QNAP with a keyboard and fired her up, spamming delete until I got the boot select screen, proving this is indeed just a low-powered x86 computer. Selecting the USB stick as the boot drive fired up OMV's installation, and I proceeded to install it with no issue. Now I do want to really quickly touch upon the server's name. As you can see from the footage, I have named the server storebox.workgroup. And the reason for the .workgroup is that I misinterpreted what the setup said about it won't being viewable on the network, as this doesn't affect Samba in any shape or form, and I could have easily used a .local name. The Storebox name is actually because for the longest time before I even got the QNAP I struggled coming up with a name. So in a similar vein to my workstation New Octane, after the original Octane failed, I named the server New Storebox. However, that isn't the end of the story. A few nights after setting up the server, I finally came up with a better name, Phoenix. But at that point, the server was all set up, and quite frankly I didn't want to go through the hassle of reinstalling and setting up everything just to change it. So the QNAP is unofficially known as Phoenix Server, despite the network broadcasting her as Storebox. In any case, enough about the naming convention and let's move on to actually setting the server up. As you can see, it is all installed now and ready to be rebooted. Upon boot up, it gives you the IP address assigned and what the default password is to log in through the web interface. And obviously they recommend to change it as soon as possible. So with that in mind, we're now switching over to New Octane to where we will configure the rest of the server. In a separate browser tab, I typed in the IP address and I am greeted with the login prompt, which is where you use the username and password they give you on the server side view. So first things first, I wanted to change the IP address to be the same as the Storebox for the sake of convenience. I went into the networking tab and chose the NIC currently connected to my router, and manually set an IP address, DNS mask and the internet router IP address. Obviously for security reasons I am not showing you this as it would be blurred anyways, but it is a pretty simple process that you can figure it out yourself. Now that it is all set up, it's time to install the Western Digital drives and talk about the file system I plan to use. The choice was very apparent from the get-go. ZFS. ZFS is very much the industry standard for managing disk arrays and doesn't suffer from the problems from traditional RAID. It is the best practice when it comes to this type of use case. However, while OpenMediaVault technically supports ZFS, it is not enabled by default the same way that TrueNAS has implemented it, and you'll need to jump through a few hoops to get it up and running. There's quite a few tutorials on YouTube on how to do this, so I won't be going into too much detail, but I will give you an abridged version of what I did. After updating the OS, I installed the OMV-Extras package and rebooted the server. Upon reboot, I go and install the Proxmox kernel as that is the kernel that has ZFS included. Now finally I can install said filing system and all the needed repositories for it to run correctly. Until now to configuring ZFS. For this I had to reboot back into the old kernel as the interface was acting kind of funky under the proper one. First I went to disks and wiped both drives. Then to create a new Z pool, I go to the add pool option and set the type to mirrored. I personally thought the correct option would have been RAID-Z1, but it turns out that is for server configurations of 3 drives or more. Choosing SDA and SDB as devices was the next step, along with naming the Z pool. In hindsight, I should have called it VDEF or Z pool, as that is more accurate to how ZFS works rather than data array. Also, apparently ZFS is automatically configured to do scrubs in OpenMediaVault, but I haven't really found it really does it each month, so I just log in and do it manually. Rebooting back into the correct kernel for ZFS to work, and the pool is showing up as it should. Now to create the share. Going to shared folders, I created a new share pointing to the Z pool and named it Storebox. Next, going to the SMB under Services, I make the folder shareable on the non-administrator account. Going into the network on New Octane, I typed in the server's IP address and signed in with my username and password, and it let me straight in. It even let me create and delete files. An immediate improvement over what I managed to achieve on my Pi server. I don't think I ever had an easier time with Samba, ever. It was dead simple to set up and configure compared to my previous encounters with said service. Performance was exactly as expected for a gigabit connection, even if it is a tad slow at 48 megabytes per second, but it showed everything is working as it should. Also, as a surprising note, I've noticed ZFS is running fine with only 4 GB of RAM. Considering how ZFS works, it is quite unexpected. So that is all the basics out of the way, but there are a few more things I want to implement to make the server better fit into her role, starting with automatic mounts. Now by default, Linux, or at least GNOME, has no easy way to have a share automatically mount upon logging on to a system. In this regard, Windows and macOS has an advantage. At first, I thought I'd need to do some complex terminal commands to achieve this, but thanks to this YouTube video by NovaSprint Tech, it introduced me to an application called Gigolo. This nifty program allows you to add and configure sys to have them automatically be mounted the moment you log in, providing the app opens. This has saved me so much time, and I love how user friendly it is. Next up is the method of backing up the files themselves. The way I usually do it is by navigating to the folders I want to back up, then copying the needed files onto the server. Obviously, this is slow, inefficient, and is prone to forgetting something via human error. So I began my hunt to look for a program to automate the task for me. Now there is actually a wide set of options depending on what you're after, but most did not have the functionality I wanted. Specifically the ability to have custom folders synced instead of either the boot drive user folders or entire drives. And the ones I did find that did have that functionality couldn't do it to a network share. Except one, however. May I present to you Locky Backup. While not the most user-friendly design you'll come across, I was able to quickly set up what folders I wanted backing up and specify where to dump it on Phoenix server. I found if you try to set up a folder in one go instead of two, it crashes the program. Having said that, however, it has worked remarkably well in keeping all my work, photos and videos backed up, and I don't have to worry if I forget something. So I am glad I discovered Locky Backup, as it has done exactly what I set out to do. And finally on the agenda for this video, Jellyfin. I suppose the easiest way was doing what I did on Storebox and install it directly through the command line. But since I want to do things properly this time around, I opted not to do that. Instead, I'm using Docker, more specifically Docker Compose, to deploy Jellyfin on Phoenix. At the time of deployment, there was only a template supplied for Plex, but not Jellyfin. This seems to have changed in the intervening months since then. So instead, I copied and pasted from Jellyfin's wiki and created the Compose container manually. And initially that didn't go so well. Since it took me a few days to figure out why it wasn't initializing, I'm not going to explain each step I took. However, this is what the Compose file looks like in its functional form if you want to copy my homework. Also, shout out to this YAML checker. It immediately told me I had an extra space where I shouldn't, which was the last element holding me back. I'll provide a link to this resource in the description, just in case you're having trouble figuring out why your Docker Compose containers won't start. So there it is, Phoenix server. Since recording all the B-roll footage you've seen, the server is still operating several months later with minimal issues. The biggest problem I'm having is that I can't get Jellyfin to play VP9 encoded files. But this is a very minor issue, all things considering. She has been really reliable so far and has perfectly been keeping my work protected in the event of a drive failure. So in that regard, this project has been a massive success. And I hope, knock on wood, that Phoenix will be running for years to come. Thank you so very much for watching this video, and I'll see you in my next one. Peace.